NASA's most powerful lunar camera has been orbiting the moon since 2009, and the things it has photographed up there should not surprise you as much as they do. The moon is not a dead, empty rock. It is an archive of everything that has happened in this solar system for 4 billion years, and the Lunar Reconnaissance Orbiter has been reading that archive 1 kilometer at a time. The Lunar Reconnaissance Orbiter, or LRO, launched on June 18, 2009, and entered lunar orbit shortly after. It carries 7 scientific instruments, but the one responsible for the most visually striking discoveries is the Lunar Reconnaissance Orbiter camera, or LROC. The narrow-angle cameras on LROC can resolve objects as small as 50 centimeters across from an orbital altitude of about 50 kilometers. That is roughly the resolution needed to photograph a large suitcase from space. Over 15 years of continuous operation, it has built the most detailed map of another world ever produced. Start with what it found from history. LRO photographed all 6 Apollo landing sites with enough resolution to see the descent stages of the lunar modules still sitting on the surface, the equipment left behind, and in some cases the tracks left by astronauts and rovers during EVAs that ended over 50 years ago. Those tracks have not eroded. There is no wind on the moon, no rain, no geological activity at the surface. The footprints Neil Armstrong left in July 1969 are still there, preserved in the regolith, exactly as they were made, slowly being degraded only by micrometeorite impacts at a rate that will take millions of years to erase them completely. LRO found something more recent and more puzzling. In 2022, it imaged a new double crater, the impact site from an unidentified rocket body that struck the far side of the moon in March of that year. The double crater indicated the impactor had significant mass at both ends, which did not match the expected configuration of the rocket stage it was initially identified as. The identity of the object and the reason for the double crater shape remain debated. It is an example of how the moon records human activity in space, whether we intend it to or not. The lava tubes are perhaps the most strategically significant discovery. LRO imaging revealed hundreds of pit entrances across the lunar maria, circular collapses in the surface that open into hollow underground spaces. These are the collapsed roofs of ancient lava tubes. Tunnels formed when flowing lava solidified on the outside, while the interior continued to drain, leaving empty passages sometimes hundreds of meters wide. In 2024, research using LRO data combined with Grail gravity data and temperature measurements confirmed that some of these pits lead to spaces that maintain a remarkably stable temperature of around 17 degrees Celsius, despite the surface cycling between 120 degrees and minus 130 degrees between day and night. That thermal stability makes lava tubes the most natural candidate for long-term human habitation on the moon. Built shelter, radiation protection, and stable temperature provided by geology. The LRO's Diviner instrument mapped the thermal environment of the entire lunar surface and confirmed the existence and distribution of the coldest natural places in the solar system. Crater floors near the South Pole that never receive sunlight and maintain temperatures below minus 163 degrees Celsius. These are the locations where water ice is most likely preserved. The LROC team also discovered something called lunar swirls, bright, curving surface patterns found at several locations that do not correspond to any obvious surface feature. These swirls are associated with localized magnetic anomalies, areas where the crust has an unusually strong remnant magnetic field. The leading hypothesis is that these regions were magnetized during ancient impact events or volcanic activity, and the magnetic field deflects solar wind particles, reducing space weathering and preserving brighter surface material. The Reiner Gamma Swirl is the most prominent and photographed example. LRO is still operating. It has returned over 1 petabyte of data, 1 million gigabytes, the most data ever returned from a planetary mission. It continues to find new landslides, fresh craters from recent impacts, and surface changes that remind scientists the moon is not as static as it appears. Follow for more on what humanity's longest-running lunar mission keeps revealing. And tell me, if lava tubes on the moon offer stable temperature, radiation shielding, and natural shelter, do you think the first permanent lunar base should be built inside one?